In this video, we're going to cover some concepts in algebra concerning applications and building linear equations from applications. We're going to create an equation, graph an equation while appropriately labeling axes, intercepts, and points, evaluate the equation, and other words for evaluating are interpolating or extrapolating. You're going to interpolate data or extrapolate data. Those are commonly used words for evaluate. They kind of mean the same thing, kind of don't. Anyway, we're also going to identify horizontal and vertical intercepts and identify their meanings in the application. And finally, talk about the slope for this application and the meaning of the slope in the application. Here's the application we're going to go ahead and tackle. You're planning a vacation. You know it'll cost about $60 per day in Germany and about $100 per day in Switzerland, and you have $1,200 to spend altogether, and that's after airfare, so we don't have to worry about flying there. We just know the per day cost for Germany and for Switzerland. First question asks us to write an equation that relates the number of days in Germany and the number of days in Switzerland. And the variables are given to us to be G and S. So if I know it costs me $60 for every single day in Germany, well, let's talk about this. If I spent 1 day in Germany, so let's let G equal 1, then the amount of money we would have spent is $60. If we were to spend 2 days in Germany, well, then that costs us $120. I'm going to write that as 60 times 2. If we spend 3 days, it would cost us obviously 3 times 60. So I'll just go ahead and write that, 60 times 3. And if we were to spend ... if we just do this on and on forever, if we were to just call that G, in other words, we spend G days in Germany, because that's what they tell me my variable is. My variable G stands for the number of days in Germany. So we spend G days in Germany. Following this pattern here, we know it's going to cost us $60 times the number of days, which is G. We'll have the same argument for how many days we're going to spend in Switzerland and how much it's going to cost, except in Switzerland's case, we're going to let S be the number of days in Switzerland. So I know that the cost for Switzerland is going to be, let's see, cost for Switzerland is 100 times S. So here's our cost for Germany. We have our cost for Switzerland, and we know that altogether it's got to sum up to $1,200 because that's what we're going to spend. You're going to spend every penny that you can. It's an implied statement within a problem. When somebody hands you a problem and says you have $1,200 to spend, it's a knee-jerk reaction that we all kind of say, well, then I can spend less than that as well. And it's actually true. In the real world, you can spend less than that. But in the math world, we tend to say we're going to spend exactly that. So here's our equation. 60G plus 100S is going to equal 1,200. However, if you have a nice instructor, they'll probably still mark you right if you write less than or equal to 1,200. So that's part A. I'll put a little check mark there to let me know that I've done that. The next part is asking me to graph this equation. And to graph this, I'm going to open up a new page here. And something I'd like you to note about how you're going to graph this is that it doesn't really matter technically what variables you use on which axes. If you're not told to use G as a horizontal variable, you're more than welcome to use S as your horizontal variable. I'm just going to use G here. So I'll let G, which is the number of days in Germany, be my horizontal variable, and I'll let S, which is our number of days in Switzerland, be our vertical variable. And let's check our equation here. Our equation says that 60G plus 100S is equal to 1,200. Let me rewrite that over here so that I have this on my paper. 60G plus 100S is equal to 1,200. The easiest way to graph this, if you have an equation like this, which is given in, I guess the best way to say this is an intercept form where you can easily find the intercepts is to pretend as though, just for a moment, that you didn't have g. In other words, pretend that g was 0. Remember, I'm saying my input variable is g, so I'm saying let g equal 0. If g is 0, you can imagine this being gone, and you can solve the resulting equation. The resulting equation tells me that s will be 12. We go ahead and do that. G is 0, s is 12. And then I'm going to do the same thing to pretend that s is 0. That's what s is right there. So I'll pretend the same stuff that I just pretended. I'll cover up that, and when you look at this, you can solve this equation, 60g is equal to 1200, to find out that g will equal 20. Let me go ahead and write that in. Alright. So we have our intercepts. Let's go ahead and graph those intercepts. And I'll do this in a different color here so that we can see them kind of nicely. 20, 0, that'll be our horizontal intercept. And then we want our vertical intercept, which is at 12, 0. So 1, 2, 3, 4, 5. Let's see, yep. 6, 7, 8, 9, 10, 11, 12. So there's our vertical intercept at a height of 12. And of course, since this is linear, because the powers on both variables are 1, these two intercepts can be connected with a straight line. So there's a graph of our situation. It's a very nice graph. We've plotted it very cleanly. We've labeled our points here. Excuse me, you might have an instructor that requires you to label these points a little more exactly, like this would be 0, 12, and this would be 20, 0. You might have an instructor like that. If that's the case, that's how it's done. So let's go ahead and go back and see what the next question is asking us. I'll put a little green check mark here as well. I'm trying to keep my voice down because I noticed my microphone level is extremely high. Okay, so if you plan on spending 10 days in Germany, how many days can you spend in Switzerland? Now this, I'm going to go ahead and use the equation. Using a graph here is a really bad idea. The graph is just to give us a visual of all the possible solutions. So this graph right here just gives us a visualization of every possible combination of days in Germany and days in Switzerland. However, if we want to evaluate how many days we can spend in Switzerland if we spend 10 days in Germany, just use the equation. The equation is 60, let me change pen colors here. The equation is 60 times g, and g in this case they're telling me is 10, plus 100s is equal to 1200. Now solving this, we will get that 100s is equal to 600, or in other words, s is equal to 6. So we can spend 6 days in Switzerland if we spend 10 days in Germany. That's a pretty quick solution there. What's the horizontal intercept and what does it mean in this situation? And now I'll go ahead and go back to that graph. The horizontal intercept is the one right here. It's the one that's actually on the horizontal axis, right? And that tells me, first of all, the horizontal intercept itself is 20, 0. Well, let me write that in. So the horizontal intercept is, sorry, I have to find my pen here, 20, 0. And what does it mean? Well, it means that if I spend 20 days, remember our horizontal variable is g, it means if I spend 20 days in Germany, I'm not spending any days in Switzerland. Now once you see that, you can probably see that the next question is going to be just as easy, because you see that the next question is just what is the vertical intercept and what does it mean in this situation. If you go to the graph here, the vertical intercept is this guy right here. And that's at 0, 12, so let me write that in. Right here, actually I'll just write it below the statement, 0, 12 is the vertical intercept. What does it mean? It means that if we spend 12 days in Switzerland, remember the second variable is always about Switzerland in this case. If I spend 12 days in Switzerland, I have no money to spend any type of day in Germany. Finally, we have to ask ourselves what this last little bit, this last question is all about. What's the slope of your equation? Now, the slope of our equation can be determined more easily from the graph itself. So let me go to the graph. Slope is rise over run, and notice in this case we actually fall. If you start right here, we fall down 12 units and we run over 20 to get to our next point. So fall means negative, so we fall 12, run 20. And of course, at this point in mathematics, no fraction should be left unreduced. You should always reduce every single fraction you see. So this will be negative 3/5 when it's reduced, or simplified, whatever you want to call it. So the slope of this equation, in my case, is negative 3/5. And I say in my case because if you set your variables up to where S is the horizontal variable and G represents the vertical variable, your slope will be a negative 5/3. Okay, but you'll have a 3 and a 5 no matter what, and it's going to be negative no matter what. So let me write that in here. The slope of our equation is going to be, where am I? Where's my pen? There it is. Okay, slope is negative 3/5, like we said earlier. But what does it mean in this situation? Remember, it's a rise over run. Let's look at the picture here. We fell a certain number of days and ran a certain number of days. Now let's write down what the vertical variable represents right here. I'll write it in red so that it really stands out. The vertical variable represents days in Switzerland. And the horizontal variable represents days in Germany. So if you look at that, it means when you lose 3 days in Switzerland, you gain, right, because that's a positive 5, you gain 5 days in Germany. This should essentially imply to you that Switzerland's more expensive. You give up 3 days there, you get 5 days in Germany. So let me write that down. Giving up, and there's a lot of ways you could have said this, by the way, but I think that this is the easiest way to understand it. So there you have it. Giving up 3 days in Switzerland will give us 5 more days in Germany. I'll put a little green check mark here saying that we're done with this. And that is a pretty nice, thorough example using linear equations